The European equivalent to National Electrical Code Section 820.33 regarding grounding is European Norm 50,310 published in 2017. This standard specifies the requirements for the safety of electrical installations in low-voltage distribution systems with nominal voltages up to 1000 volts alternating current or 1500 volts direct current. European Norm 50,310 2017 includes a section on grounding, which is similar to National Electrical Code Section 820.33. This section specifies the requirements for the grounding of electrical installations, including the use of grounding electrodes, grounding conductors, and grounding connections. There are some key comparison points between National Electrical Code Section 820.33 and European Norm 50,310 2017. Firstly, consider the scope. Secondly, the definitions. Thirdly, the general requirements. Fourthly, grounding electrodes. Fifthly, grounding conductors. Sixthly, grounding connections. And finally, testing. As you can see, the two standards are very similar in content. The main difference is that European Norm 50,310 2017 is more specific in some areas, such as the requirements for grounding electrodes and grounding conductors. Grounding electrodes are conductive objects that are buried in the earth and used to provide a low impedance path for fault current to return to the source. The grounding electrode system is a critical part of any electrical system, as it helps to protect people and equipment from electrical shock and damage. There are many different types of grounding electrodes, but some of the most common include ground rods, ground plates, and underground metallic water pipes. Ground rods are typically made of copper or steel and are driven into the ground to a depth of at least 8 feet. Ground plates are typically made of copper or steel and are buried horizontally in the ground at a depth of at least 2.5 feet. Underground metallic water pipes can be used as grounding electrodes if they are in direct contact with the earth for at least 10 feet. The size and type of grounding electrode that is required for a particular electrical system will depend on the size of the system and the type of soil in which the electrode is installed. The National Electrical Code and European Norm 50,310 provide detailed requirements for grounding electrodes. Grounding conductors are used to connect the grounding electrode to the electrical system. Grounding conductors must be sized according to the size of the electrical system and must be made of copper or other approved material. The National Electrical Code and European Norm 50,310 provide detailed requirements for grounding conductors. Grounding connections are used to connect the grounding conductors to the grounding electrode and to the electrical system. Grounding connections must be made using approved methods and materials. The National Electrical Code and European Norm 50,310 provide detailed requirements for grounding connections. Grounding is an essential part of any electrical system. By following the requirements of the National Electrical Code and European Norm 50,310, you can ensure that your electrical system is properly grounded and that people and equipment are protected from electrical shock and damage. Grounding ensures a safe path for fault currents, minimizing the risk of electrical shock. Effective grounding helps stabilize voltage levels, preventing equipment malfunction. Grounding diverts lightning strikes safely to the ground, protecting structures and electronics. Proper grounding reduces electromagnetic interference, improving signal quality. Grounding prevents static electricity buildup, especially important in sensitive environments. Grounding extends the lifespan of electrical equipment by minimizing stress from voltage surges. Grounding is mandated by electrical codes for safety and compliance. Regular inspection and maintenance of grounding systems are crucial. Use appropriate grounding techniques for different soil conditions. Ensure all grounding connections are secure and corrosion resistant. Choose grounding conductors of adequate size for the expected fault current. Grounding should be done by qualified electricians to ensure safety and compliance. Always disconnect power before working on any electrical system. Use personal protective equipment, such as insulated gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental energization. Inspect grounding systems regularly for damage or corrosion. Test grounding systems periodically to ensure they are functioning properly. Keep detailed records of all grounding system inspections and maintenance. Immediately address any grounding issues to prevent potential hazards. Educate yourself and others about the importance of grounding. Stay updated on the latest electrical codes and standards. Grounding is a critical safety measure that should never be overlooked. Proper grounding can save lives and prevent property damage. Always prioritize safety when working with electricity. The information presented here is for general knowledge and informational purposes only, and does not constitute professional advice. Always consult with a qualified electrician for any electrical work or specific applications. Electrical codes and regulations vary by location, so ensure compliance with local requirements. Grounding is a complex topic, and there are many factors to consider. The information provided here is not exhaustive, and further research may be necessary. Stay informed about grounding best practices to ensure a safe electrical environment. Grounding is an ongoing process that requires continuous attention and maintenance. By taking the necessary precautions, you can minimize the risks associated with electricity. Remember, safety is always the top priority when working with electrical systems. Grounding helps to protect sensitive electronic equipment from damage due to voltage spikes and surges. Grounding plays a critical role in ensuring the reliable operation of electrical systems. A properly grounded system minimizes the risk of fire hazards. Grounding improves the overall efficiency of electrical systems. Grounding helps to reduce the risk of data loss due to electrical disturbances. Grounding is essential for the proper functioning of many types of electronic devices. Grounding helps to prevent the buildup of static electricity, which can damage sensitive components. Grounding is a key component of electromagnetic compatibility, or EMC. EMC refers to the ability of electrical equipment to function correctly in its electromagnetic environment without causing interference to other equipment. Grounding helps to minimize the emission of electromagnetic interference from electrical equipment. Grounding also helps to protect electrical equipment from electromagnetic interference from external sources. Grounding is an important consideration in the design of electrical systems. The design of the grounding system should take into account the specific requirements of the application. Grounding systems should be designed to minimize the impedance of the ground path. The impedance of the ground path is the resistance to the flow of current through the ground. A low impedance ground path is essential for effective grounding. Grounding systems should also be designed to provide a safe path for fault currents. Fault currents are the currents that flow when there is a short circuit in an electrical system. A safe path for fault currents is essential to prevent electrical shock and fire hazards. Grounding systems should be inspected and tested regularly to ensure that they are functioning properly. Grounding systems should be maintained in good condition to ensure their continued effectiveness. Grounding is a critical safety measure that should never be neglected. Proper grounding can save lives and prevent property damage. Always consult with a qualified electrician for any questions or concerns about grounding. Grounding is a complex topic, but it is essential to understand the basics. By following the recommendations in this guide, you can help to ensure that your electrical system is properly grounded and that you are protected from electrical hazards. Remember to consult local electrical codes and regulations for specific requirements. The National Electrical Code and European Norm 50,310 provide comprehensive guidelines for grounding electrical systems. These standards are updated regularly to reflect the latest advances in technology and safety practices. Staying informed about the latest electrical codes and standards is essential for ensuring the safety of electrical systems. Grounding is an integral part of a comprehensive electrical safety program. A comprehensive electrical safety program should include training, procedures, and equipment to protect workers from electrical hazards. Grounding is an important element of electrical safety training. Workers should be trained in the proper procedures for grounding electrical equipment. Workers should also be trained in the hazards of improper grounding. Grounding procedures should be followed carefully to ensure the safety of workers. Grounding equipment should be inspected regularly to ensure that it is in good working condition. Grounding is a shared responsibility. Everyone who works with electricity should be aware of the importance of grounding and should take steps to ensure that electrical systems are properly grounded. Grounding is a fundamental principle of electrical safety. By understanding the principles of grounding and following the proper procedures, you can help to protect yourself and others from electrical hazards. Remember to always consult with a qualified electrician for any questions or concerns about electrical safety. Grounding is a critical safety measure that should never be taken lightly. Proper grounding can save lives and prevent property damage.